Hello everyone, welcome back to my channel. Today I will show you how you can get 3-level output from a single phase H-bridge inverter circuit using phase shifted PWM technique. So before I starting to the design, I request you to subscribe my channel and check out my other videos on Matlab and Altium PCB designs. So let's start. So in the phase shifted PWM technique, the carrier signals are phase shifted by a defined angle. Like for 3 level, we required 2 carrier signals which will be 180-degree phase shifted to each other. Same as for 4 level, we will require 3 carrier signals with 120-degree phase shifted to each other. So by increasing the level, you have to add more carrier signals. The carrier signals are equally phase shifted to each other. So let's start with the 3-level design. Here a sine wave is taken as a reference signal and the triangular wave as a carrier signal. Now we are giving the switching frequency as 100 Hz. So you can see the overall time here is 0 to 4. So the total time, that is 4 divided by 400. That means 1 by 100. That means the frequency is 100 Hz. Because we know that time is inversely proportional to the frequency. Now just run the simulation and check the waveforms of the carrier and reference signal. Now change the frequency to 1000 Hz. So you can see one of the carrier signal is generated. Now we have to generate another carrier signal which will be phase shifted by 180 degree from the first carrier signal. So here you need to use the transport delay block to perform the phase shift. Here you have to give the time delay. Total time t is equal with 360 degree. That means 180 degree will be t by 2. And here t equal to 1 by 1000. That means the total delay will be 1 by 2000. which is 0.0005. Also put the same value in initial output. So you can see that second carrier signal is 180 degree phase shifted to the first carrier signal. Now generate the PWM gate pulse by comparing the reference and the carrier signal. So basically I will show you two types of PWM generation techniques. First one will be normal PWM generation, just directly giving the comparator value to the switches. And the second one will be the most prominent one, that is give the exact time value depend on the corresponding level that the specific switches will be on. So first give the comparator value directly to the switches and check the output. So this is the gate signals. And this is, you can see the 3-level output, but this is not the perfect output. The frequency to 10,000 Hz or 10 kHz and check the output. So now let's design the second technique, which I have already explained in many of my videos, like 3-level, 5-level phase disposition PWM technique, diode clamp multi-level inverter technique, flying capacitor models. I will put all the links in the description box. So according to the switching states, switch S1 will on at top level, that is level 2, and middle level, that is level 1 or 0. First I want to tell you that I am naming the VDC as a level 2, 0 as level 1 and minus VDC as level 0. Now switch S2 will on only at the top level, or we can say for the level 2 operation. Switch S3 will on for level 1 as well as level 0, that means 0 voltage level and minus VDC voltage level. Switch S4 will on only at the time of minus VDC, or we can say at level 0. So now run the simulation and check the output. So now you can see this is the perfect 3-level output. Now let's change the frequency to 1000 Hz and check the output. I think it is clear that how you can design a 3-level H-bridge inverter using phase shifted PWM. So if you like this video, please hit the like button. For latest video update, subscribe to my channel. Thanks for watching.